In this video, I'm going to show you how to find the greatest common factor for both numbers and letters. And in a previous video, I went through how to find the greatest common factor of just number terms. And what we did was we looked at the factors that multiplied to make, for example, 12 and 60. But now what we're going to do is incorporate some letters. And so not only will our factors have numbers, but they will also have variables. So to find the GCF, first, what you want to do is find the GCF of the coefficients, just like what we did in this previous example, finding the largest factor that goes in. And then what we do is choose the factor of the smallest exponent for the variables. So greatest common factor for the numbers really is indeed the greatest factor that all three have in common. Now 27, 3, and 9, all of those numbers are divisible by a factor of 3. And now when I look at the letters, if I look at the first term with 27x squared y cubed z squared for the variable x. So what I'm going to do is look at the x here in each of my terms. And for the variables, this is how you find the GCF. And I know this might seem weird, but it's the max you can take out of each letter. Now, if this term has 2 x's, and this term has 4, and this term has 3, what amount can you take away from every term? And what it's going to be is the smallest amount, because if this only has 2 x's, the max x's you can take out as a GCF is 2. I can't take out 3 because this one doesn't have 3 to take out. So for the variables, you look for the smallest power. And so between the x's, the x squared is the smallest power. And so I'm going to circle that one here. And then for my y's, y cubed, y squared, and y to the first, the smallest amount of those y's is just 1y. So I'm going to circle that. And then z's. This one has 2 z's, this one has 1 z, and this one has no z's. So we would take out no z's, no letter z, because this one doesn't have a z to take away, so that can't be a greatest common factor if it doesn't have a z as part of the term. So for the numbers, it is the greatest common factor that they both share in common, but for the letters, it's the smallest of the powers. And so I want to show you with 6 examples here in this video. So the GCF of these monomials, so 6x squared would be, for this term, between the numbers 6 and 5. 1 times 6 multiplies to make 6, and 2 times 3. And for 5, 1 times 5 multiplies to make 5. And so the greatest common factor that both of those have is the number 1. And for x squared and x to the third, x squared is x times x, and x to the third is x times x times x. So what do they both have in common? They both have in common the x squared. So my GCF will be 1x squared, or you would just write it x squared. So it's the number and then the letters that they both have. For 15y cubed, first going to look at the number, and for negative 20y, I'm going to look at the number. So for this one, 1 times 15, 5 times 3, and for here, 1 times 20, 2 times 10, 4 times 5. Both of these have in common, for the highest number that goes in, the number of 5, so that's your greatest common factor. And for y cubed, this is a y times a y times a y, and 1y is just y. So what do they both have in common? 1y. So my GCF would be 5y. And then again here for this example, 16q to the fourth and 8q squared. Between 16 and 8, the greatest common factor is 8. And for q to the fourth, this is q times q times q times q, and q squared is q times q. So what do they both have in common? They both have 2 q's in common, so 8q squared would be my GCF. And I have 2 more examples here on the next page of your notebook, and it is 3x squared and a 6x. Well, both of those 2 numbers are divisible by 3. And then for x squared and for x, if this is x times x and this only has 1, the greatest common factor is what they both have. So my GCF here, put them together, the 3 and the 1x, I have 3x. And for 64 n to the 5th and 24 n to the 2nd, between 64 and 24, list out all your factors if you need to. Or just think about what's the biggest number that multiplies to make both. For these, 8 is the biggest number that goes into both 64 and 24. And for n to the 5th and n squared, n to the 5th is 5 n's multiplied, and n squared is 2 n's multiplied. So what do they both have in common? They both have in common n squared. So put your number and your letters together. 8n squared is our GCF here. And then for 8 and 7, 7 is prime, so the only thing that's going to go into these is the number 1. And for x and an x squared, the smaller of the power is just 1x. So 1x, I don't really need the coefficient of 1 is my GCF. So 1x, and that's it. Again, I don't really need that coefficient of 1, so I'm going to erase it. Stay tuned for the next video to show you how we're going to then factor out our greatest common factor.